Hello friends, welcome to Bhavesh Sir ki online class. Let us enjoy the video lecture. Dear friends, universally it is accepted 0 degree, 30 degree, 45 degree, 60 degree and 90 degree are called as standard angles. Internationally it is accepted. And remember my dear friends, you have to find out or remember sine 0 degree, sine 30 degree, sine 45 degree, sine 60 degree, sine 90 degree. That means for sine ratio you remember 1, 2, 3, 4, 5 values. Likewise remaining 5 ratios, that is 6 ratios multiplied by 5, that is 30 ratios one has to remember. And mind it very well to remember all 30 ratios. It's a bit cumbersome or a bit tedious. I'm trying to make it simpler. I've kept a part blank over here. Purposely I've kept a part blank over here. I'm taking sine ratio first, but before that you just see what I'm going to do. Math starts with you started with knowing nothing, that is 0. Then you learn first step, you learn second step, you learned third step, you learned fourth step. So what I've done, I've written 0, 1, 2, 3, 4. Dividing each number by 4, fine. Dividing each number by 4, I will get 0 over 4 as 0, 1 over 4 as 1 over 4, 2 over 4 is 1 upon 2, cancellation will take place, and here 3 upon 4 and 4 upon 4 is 1. I repeat, what did I do? I wrote for 0, 1, 2, 3, 4. Then I divided each number by 4 and I got the result. From this result, I am taking square root of each result. I am taking square root of each result. So square root of 0 is 0. I am taking square root of 1 upon 4. You know 1 is a wonderful number. Square root of 1 is 1. Square root of 4 will be 1 upon 2. I have to take square root of this 1 over root 2. We cannot find out the square root of 2, so it is root 2. I am taking square root of 3 upon 4. Square root of 3 is not possible, that is root 3. Square root of 4 will be 2. And I have to take square root of 1. And I told you 1 is a wonderful number, so square root of 1 is 1. What does this mean, my dear friends? It means that if I am taking, see, we learned in the previous part that we write down sine theta, and I told you theta is a symbol used for some unknown angle. Now suppose somebody is asking me what is the sine of 0 degree, then sine of 0 degree is 0. If somebody is asking me what is sine of 30 degree, then sine of 30 degree is 1 upon 2. Somebody is asking me, sir, how much is sine 45 degree? Then sine of 145 is 1 over root 2. Likewise, from the table, you can remember 5 values of sine ratio. I told you we have to remember 30 ratios. Out of that, we learned 5 how to find out. Then what about the remaining ones? I'm making you understand, I'm making you comfortable that how can we go about it. Remember, sine and cos are always walking in opposite direction. If one goes in north, other will go into south. What I mean to say is, we started as sine 0 was 0. So cos will always take the opposite of that. So sine 0 is 0. This 0 I have to write down over here. So cos of 90 will be equal to 0. So यहाँ का फर्स्ट नंबर यहाँ पे लास्ट हो गया, तो यहाँ का लास्ट नंबर जो है यहाँ पर क्या हो जाएगा? फर्स्ट हो जाएगा. Second will go to second last. This will come second, and this has no choice. It will remain as it is. So if somebody is asking me what is cos 0, cos 0 will be equal to 1. Cos of 30 is equal to root 3 upon 2. Cos of 45 is 1 over root 2. Cos of 60 is 1 upon 2, and cos of 90 is equal to 0. Now, my dear friends, before I explain how to calculate 10 ratio of all the 5 angles, I would just like to bring to your notice, here see 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. As the value of theta is increasing, what is happening to sine? Sine 0, 1 upon 2, 1 upon root 2, root 3 upon 2 and 1. So whenever theta increases, sine also increases. What happens? What is the trend in cos theta? See here, 0 degree, 30, 45, 60, 90. What happens to cos? 1, root 3 upon 2, 1 upon root 2, 1 upon 2 and 0. So trend of cos theta, as theta increases, value of cos decreases. Now coming to the topic of tan theta, how to calculate the value of tan theta. Then if you remember the fourth result, that tan theta, I would just remind you what was that result. Tan theta is nothing else but sine theta divided by cos theta. This was the fourth result we did. Tan theta is equal to sine theta upon cos theta. Sine theta divided by cos theta, that is 0 upon 1. 0 divided by any non-zero number, answer is 0. 1 upon 2 divided by root 3 upon 2. Your answer will be 1 upon root 3. 1 upon root 2 divided by 1 upon root 2. Any non-zero number divided by itself, answer is 1. So here is 1. So tan 0 is 0. Tan 30 degrees 1 upon root 3. Tan 45 degrees 1. Here it will be root 3. And remember, 1 over 0. This is, I am writing ND. ND means not defined. Remember, if you divide any number by 0, then it is not yet defined in mathematics. So division by 0 is not defined, hence tan 90 degree is not defined. Tan 0 degree is 0, tan 30 degree is 1 upon root 3, tan 45 degree is 1, tan 60 is root 3, tan 90 is not defined. I told you that we are supposed to read or learn 30 values. Just now we have completed 15 values, remaining 15 values to be done. But again, not to worry much about it. If you know sine ratio or sine values, you can find out cosec values very easily, because we have learned the first result that cosec and sine are multiplicative inverse of each other. That means whatever is sine theta value, if you make a multiplicative inverse of that, you will get cosec value. What I mean to say for example, sine theta is 1 upon 2. Its multiplicative inverse is 2 upon 1. So cosec 30 degrees 2 upon 1, which we practically write it down as 2. Here cosec 45, root 2 upon 1, but practically we'll write it down as root 2. Cosec 60 will be equal to 2 over root 3. Cosec 90 will be 1. Interesting part here, cosec 0 degree. Then this 0 is 0 upon 1, that is 1 over 0. And few minutes back we learned that division by 0 in mathematics is not defined, and cosec 0 will be equal to not defined. Now coming back to the concept of sec ratios, sec and cosec walk exactly in the opposite direction. One walks in north, other will walk in south. What I mean to say is cosec 0 is not defined. This will go to last column over here, not defined. This will be over here as 1. The second value will become second last value. Second last value will become second value, and this becomes root 2. So these are the more 10 values. These two rows make more 10 values. 15 values we learnt. And somebody will ask me, sir, what are the values of cot theta? Then cot theta, before I go on to cot theta, I will just write down tan theta over here. 10 values, if you remember, all the values 0. This was 1 over root 3. This was 1. This was root 3. Here it was not defined. We did a few minutes back. If somebody is asking me, sir, what are the values of cot theta? Then again, cot theta and tan theta both walk in opposite direction. This will be not defined. This will be root 3. This will be 1. This will be 1 upon root 3. and this will be 0. My dear friends, to make and remember this table, you will require at least 5 times practice of this particular table, how to make it. I'm just revising first part of the table, how to make sine theta. From sine, the remaining values you can find it out. What did I do was I wrote 0, 1, 2, 3, 4. Each number I divided by 4. Whatever result I got, which I have circled in red, its square root was taken by me, and the square root will give me the value of corresponding sign. So here 0 का square root 0, 1 upon 4 का square root 1 upon 2, 1 upon 2 का square root 1 upon root 2, square root of 3 upon 4 is square root of 3 divided by 2, and square root of 1 is 1. And then rest of the things like sine and cos go north-south direction. Then how to find out tan theta, tan was sine upon cos. Then how cosec works, cosec is multiplicative inverse of sine. Cosec and sec has a north-south direction walking, same way tan theta and cot theta. You'll at least write down this 5 times. I broke down the table and wrote, I would suggest you will make on a paper all the 30 values together, and first row you will keep it blank like this. You blank means not sine cos something. First no heading over here, then sine cos, tan, cot, sec, cosec, likewise 8 rows you will be making. First will be standard angles, second row no heading over here, then all the 6 ratios, and here vertical columns you will make. Dear friends, we are going to start with a topic from trigonometry, chapter number 23, trigonometrical ratios of standard angles. The name itself suggests that we are going to talk about standard angles, and we know standard angles are 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So in this chapter we have to know this many angles, and we will be dealing with this many angles only. For dealing so many angles, you have already made a table of 30 values if you remember. So we are going to remember all those 30 values, and I know that in the first step you may not remember all 30 values. So I would suggest at initial stage, only for initial stage or for the first exercise, you can refer to the table. And once you have remembered all the values, you can do it directly. Right now you can use the tables. The questions I am taking from exercise 23A. Few questions we will talk. Today we will talk about exercise 23A. First question they have asked is sub question 1, sine 30 degree into cos 30 degree. My dear friends, you should know the value of sine 30. You have to just substitute 1 upon 2 multiplied by root 3 upon 2. Remember, numerator will multiply to numerator, denominator will multiply to denominator. If there is any cancellation possible, you have to do the cancellation. Now let me tell you, once you put up the values, next part, you should know the arithmetic very well. What I mean to say arithmetic is sometimes you come across something like this, 1 upon 2 plus 1 upon 3 minus 4 upon 5. So if you are not very familiar with such kind of calculation, initial stage, you may find it difficult. You have to master this particular thing. This fraction calculations you have studied in grade 5. So you have to revise your grade 5 calculations. If you are not sure about this, you may find this exercise difficult. Exercise is not difficult. Your basic concepts may not be clear, so you may find it difficult. Second sub question what I am going to take is fourth sub question. I mean to say question 1, fourth sub question, that is cosec square. I made an error over here. It is cosec square 60 degree minus tan square 30 degree. Now remember, when I say cosec square 60 degree, what does it mean? I have to find out the value of cosec 60, that is 2 upon 3 cos square. Find square of the value of cosec 60. Cosec 60 from table you can find it out. It is 2 upon root 3. So 2 upon root 3 the whole square minus tan 30. You can take values from the table. 1 upon root 3 the whole square. Now 2 square is 4. Root 3 square is 3. 1 upon 3. 4 minus 1 whole over 3. That is 3 over 3. Final answer is 1. So dear friends, I reminded you, if you are not sure about this particular concept of fractions, adding, subtracting, then you may find little difficult in this exercise. Otherwise, let me tell you, entire chapter is based only on those 30 values what we learned. We'll move on to one more sub-question. Sub-question number 5 from question 1. It states that sine square 30 plus cos square 30 plus cot square 45. Now, as I told you, one should know the values. 1 upon 2, sine 30 is 1 upon 2, that is 1 upon 2 square. Cos square 30 is nothing else but root 3 upon 2 the whole square. Cot square 45 will be replaced by 1 square. So this is 1 over 4 plus 3 over 4 plus 1. 1 plus 3 all divided by 4. 4 over 4 plus 1. 1 plus 1. Your final answer is 2. So you should know the values, 30 values. You should know how to substitute, how to square. And once that is done, this part onwards, this line onwards, here, this line onwards is nothing else but pure arithmetic, which you learnt in grade 5 or grade 6, addition, subtraction of fractions. We shall see, prove that kind of questions. They have asked us, PT here means prove that. Sometimes I may write down ST, that is show that, prove that, show that. Such kind of questions whenever comes, how to solve those questions. We have to prove that sine 60, I put dot over here between sine 60 and cos 30. Whenever there is a dot, that means it is multiplication. Sine 60 into cos 30 plus cos 60 into sine 30 equal to 1. We are supposed to prove this, all values together, combined together, comes to 1. Whenever there is to prove kind of question or prove that, show that kind of question, your solution will begin with proof. Fine, this is one important aspect for you. It is not solution. Don't write SOL, write down proof. And whenever trigo proof comes into play, even in grade 10, you have to just take LHS first. That is LHS is left hand side. Left hand side of what? Of to prove का equal to के sine का left side की जो चीजें है, that is called as LHS. So here sine of 60 degree dot cos of 30 degree, dot means multiplication, I told you, cos 60 degree. Sir, you have not put dot over here. Okay, if you put dot or do not put dot, still it means they are multiplied. Sine 60 is nothing else but root 3 over 2 multiplied by cos 30 is nothing else but root 3 by 2. Now, of course, I'll do this calculation also, but let me finish with this. 2 2s are 4. Root 3 into root 3 is 3 plus cos 60 is 1 over 2 multiplied by sine 30, that is also 1 over 2. Now I multiply this, 1 1s are 1 over 4, and if you know the fraction, addition, subtraction, so your LHS value, what you have proved, LHS value is 1, and what was in RHS? RHS is also 1. So I have proven that left hand side is equal to right hand side. That is a proof of this particular question. Dear friends, this exercise, as I told you, you should know those 30 values of the tabular values of the standard angles for all the 6 ratios. Apart from that, you should know the basic concept of addition, subtraction of fractions. One more concept you should know, which is called as rationalizing the numbers. That is called as a rationalization. Now, before I go into rationalization, I would just like to ask you a simple question, that if I ask you what is square root of 1, you can say it is 1. If I ask you what is square root of 4, you'll answer me 2. If I ask you square root of 9, you'll answer me 3. Am I right? If you remember this, 1, 4, 9, 16, 25, these all are perfect squares. If I take the square root of those perfect squares, I will get a particular number which is non-decimal. It can be represented in the form of a fraction. But if I talk about root 2, root 3, root 5, root 6, root 7, root 8, root 9, and blah 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 blah, so many questions, not root 9, root 10, blah 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 blah, so many numbers. This all numbers decimal form, if you try to see in your calculator, it will be something decimal 1.414 blah 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 blah. Here it will be 1.732 blah 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 blah. It never comes to an end. Such kind of numbers, this all numbers are called as irrational numbers. Now if I talk about root 2, so root 2 is an irrational number. Now if I want to make this irrational number a rational number, what I have to do is root 2 multiplied by root 2, then it will be 2. So what I have done is multiplying root 2 by root 2, it gives me a rational number. So I can say if I want to rationalize root 2, then rationalizing factor of root 2 is root 2. I will explain you with one more example so it makes clearer for you. Say for example, I'm in 3 root 5 and I tell you to rationalize 3 root 5. Now my dear friends, 3 root 5 has two components. One is 3 and other is root 5. Out of these 3 components, first component is 3. 3 itself is a rational number, so I don't have to multiply it by 3. What I will do is 3 root 5 multiplied by root 5. Fine, it will give me 3 into 3 as it is. Root 5 into root 5 is 5 equal to 15. So which number makes 3 root 5 a rational number? Root 5. So rationalizing factor, which often we call it as RF, rationalizing factor of 3 root 5 is root 5. What example I took was a monomial. This is also a monomial. Now we shall see how to rationalize a binomial. Now I have taken a binomial, root 3 plus root 2. Both of them are irrational numbers. I have to rationalize them, and I would just remind you, when I say rationalize the number, that means I have to make that irrational number into rational number by multiplying with a suitable number. In the previous monomials, if you remember, suppose if I ask you root 7, what will be, or say 8 root 7, what will be its its rationalizing factor? Then its irrational part was root 7. So you just multiply by root 7 and you get it the rational number. So when it was monomial, it was not a difficult task for you. Now even binomial is not a difficult task. You have to just understand this very well, that root 3 plus root 2, if I multiply it by, you see this, what, by which number I am multiplying? Root 3 minus root 2. See the thing, what I have changed is their connecting sign. Here was positive, here is negative. If I multiply these two numbers, then what I will get over here is root 3 square minus root 2 square, which will be nothing else but 3 minus 2, which is equal to 1. So what is my conclusion over here? What is my conclusion over here? My conclusion over here is RF of root 3 plus 2, root 3 plus root 2 is root 3 minus root 2. In fact, I can say reverse way also, that rationalizing factor of root 3 minus root 2 is root 3 plus root 2. My simple question to you is, can you tell me without actual calculation what will be rationalizing factor of root 3 minus 1? I am asking what is RF. And I just explained you that whatever is connecting sign, write the opposite sign of the connecting sign and multiply both of them. You'll get its rationalizing factor. Let us check it out, whatever I said is right or not. Root 3 minus 1 into root 3 plus 1 is equal to root 3 into root 3 is root 3 squared minus 1 squared, which is equal to 3 minus 1, which is equal to 2. 2 is a rational number. Hence, root 3 minus 1 and root 3 plus 1 are rationalizing factors of each other. Just now you understood that if one is rationalizing factor of second, then second is the rationalizing factor of the first one. Why I have taught you this particular question, or with this particular question, concept of rationalization, you should know it that in few of the questions, you may get something like that. 1 upon root 5 minus root 3, and internationally it is decided that denominator cannot be an irrational number, or denominator should not be an irrational number. So I want to make denominator a rational number. What shall I do is root 5 minus root 3. This is binomial, and I hope you recall this particular concept, that root 5 minus root 3. Here I will write down root 5 plus root 3. And in denominator, if I multiply by some number, I have to multiply same number in the numerator. Right? What will happen? Root 5 plus root 3 over root 5 squared minus root 3 squared. So root 5 plus root 3 whole divided by 5 minus 3. Now you may ask me a question, sir, denominator is rational number but numerator is irrational number. Dear friends, when I started off with this particular concept, that time I told you that most of the time at many places throughout the world, we see to it that denominator should not be an irrational number. So we have rationalized the denominator. This particular application of rationalization is at multiple places in exercise 23A. I will expect you to apply this particular concept over there. Values may be different, but concept remains the same. And most of the time there is rationalization of binomial. I have explained you with 3 different examples. I wish you good luck and try to solve your exercise 23A.